Hi, I'm Adolph Oliver, and this is a video clip about negative exponents. Now, so far, you've only had exponents that have been nice positive integers, but exponents can be negative like this, and of course, they can be fractions and decimals and all kinds of things. So anyway, here's our next step. First off, how do you evaluate a negative exponent? I don't know how to do that. I know, of course, if it was positive, 2 to the third would just mean 2 times 2 times 2, but that would be 2 to the plus 3. So one of the things we have to do is be able to evaluate negative exponents by changing them to positive, and the key is to jump them across the fraction bar, and that changes the sign of the exponent. But I want to remind you, it doesn't change the sign of the base. Okay, so we're going to have to realize that the sign of the exponent and the sign of the base are two different things. One other thing to remember is that final answers should not have negative exponents in them. If you're directed to do so, okay, but that's very seldom. And so as a standing rule, no negative exponents in final answers. Well, let's take a look at some beginning things. Remember, 2 to the negative 3, I don't know how to evaluate that, but if I put a fraction bar underneath it here, then I can jump it downstairs, okay? I can take 2 to the negative 3 over 1, and if I jump it down, and of course if I jump everything, there's a 1 left upstairs, but it becomes 2 to the positive 3, and of course that's just 1 over 8 because we know 2 times 2 times 2 equals 8. Well, likewise, if I have a negative exponent downstairs and jump at the other side of the fraction bar, then what it becomes, since we jump everything, we got a 1 downstairs, and it changes the sign of the exponent, and this becomes 3 to the positive 2. Well, 3 squared is just 9. 9 over 1, well, that's just 9. Now, we can also jump guys that have positive exponents. Remember, 1 over 4 is officially 1 over 4 to the first power. If you do jump at the other side of the fraction bar, then the plus exponent becomes a minus exponent. And if you jump everything, then it's 1, so this just equals 4 to the negative 1. Well, there'll be occasions when we'll do this to help solve a problem, but remember, in final answers, we're always going to want our exponents to be positive. Now, let me demonstrate to you that this really works. It's simple. You see this 2 to the negative 3 over 1 that we had to begin with? Let me multiply it by something that equals 1. And I'm going to multiply it by 2 to the third over 2 to the third. Now remember, numerator and denominator are the same, so this guy's equal to 1. You never change the value of anything when you multiply it by 1. You may change what it looks like, but not its value. Well now, remember, we use the product rule here to add the exponents together to see how many 2's we have. And upstairs, I've got negative 3 plus 3, 2 to the 0. Downstairs, I've got 1 times 2 to the 3. Well, I think you remember that 2 to the 0 just equals 1. So this is 1 over 2 to the third power. Well, that's exactly what we showed you right up front. We're always going to jump at the other side and change the sign without thinking about it, but this proves that it works. Now, speaking about this 2 to the 0 power equals 1, let's look at this example down here in the bottom where I've got 2 to the third over 2 to the third. Now, what I'm going to do is take the guy in the bottom and jump him upstairs. Okay, now remember, we already had the 2 to the third upstairs. Here he is. But if I jump this 2 to the plus 3 upstairs, it'll become times 2 to the negative 3. And if I jump everything, there's a 1 left, as we saw here. Okay, so notice what I've got now. Got a 1 downstairs. The answer just the upstairs. Well, 2 to the third times 2 to the negative 3. Bases are the same. So we simply add the exponents. Well, 3 minus 3 is 0. Well, now, of course, look back to the beginning of this. Notice that I add 2 to the third over 2 to the third. Numerator and denominator are the same, aren't they? So that has to equal 1. So guess what? I just showed you that 2 to the 0 equals 1. And you can play this game with any base. So what this tells you is that for all x values here, any value raised to the 0 power equals 1. Okay, well, let's take a look at some examples now of this. And here comes the first ones that we'll take a look at. Some of this we've done already and it'll go pretty quick. So here we go. I've got 2 to the third times 3 to the negative 1. Well, those are the same bases, so I know I just add the exponents. 3 minus 1 is 2. And of course, if it's a simple answer like this that we can power out, we should. 3 squared equals 9. Now, the next one coming up, just pointing out to you that you have to be careful. 3n to the negative 3. Remember, the negative 3 is just the exponent to the end. The 3 has its own power. If you don't see it, we assume 1. And the same with the second guy here. The negative 2 exponent only goes to the end. They only go with the guys immediately in front. The 3 is too far away. It has its own exponent. So what we really got here is 3 to the 1 times 3 to the 1. Okay, we could write that, using the power rule as 3 squared. And then I've got n to the negative 3 times n to the negative 2. Well, we combine the powers of this. Negative 3 and negative 2 is negative 5. Well, can't leave the answer like this. Remember, no negative exponents in the final answer. So I'm going to make a fraction bar here, and I'm going to jump this guy downstairs. Well, now, here's what we're going to end up with. The 3 squared remains upstairs because it's got a positive exponent. If I jumped it downstairs, it'd be negative, and that's not what we're supposed to do. So 3 squared, and it's easy enough to power out, it's just 9. But the n to the negative 5 going downstairs becomes n to the positive 5. Okay, there we are. Now, another example here. We'll often find negative exponents in fractions like this. Now, here's the thing to do. Clean up the top and the bottom first, and then we'll get rid of the negative exponents. The top is nice and clean at the moment. It does have a negative exponent. We will get rid of it, but not yet. Okay. Now, downstairs here, notice we've got a power to power. Anytime you have a power outside a set of parents, you need to do that power to power first. Then you can use the product rule. Well, remember, power to power means we multiply the exponents. So this is 2 to the 3 times 3, which is 9. And of course, what we have in front, 2 to the 4th. Well, okay. Look at what we got here. It's the same base. 4 2's here, 9 of them here. We simply use the product rule and add the 4 and 9 together, and I get 2 to the 13th. Well, now, can't have negative exponents in the final answer. So when you get down to the tail end like this and you're ready to try and reduce the fraction or anything, first get rid of negative exponents. Don't try to reduce negative exponents. They go backwards from normal reducing, and that'll just drive you nuts. So here we go. I'm going to jump this 2 to the negative 4 down as positive 2 to the 4. Okay, it's been jumped down, so there's a 1 left upstairs. So I end up with 1 over, Well, these are all the same base, so 13 plus 4, 2 to the 17. Now, no negative exponents in that, so we're good right at that point. Okay, well, here's a few more little twists and turns to look at. The first example up here. Remember again, the exponents right behind the x only go to the guy in front. So this negative 3 exponent only hits the x, not the 2. The 2 has its own exponent. If you don't see anything, we assume it to be 1. Same with this x to the 0. It only hits the x, the 0 exponent. The 2 is too far away. It has its own exponent. Well, okay, first, remember x to the 0, as we just demonstrated, equals 1. So what we really have here is first 2 times 2. I can just write that as 4. Okay, and then I have x to the negative 3. No other x's here. Remember, that became a 1. So x to the negative 3. Well, this being the final answer, we can't have a negative exponent. We got to kick this guy downstairs. Now remember, the 4 officially has its own exponent of plus 1. Don't kick it downstairs. You'll make it 4 to the negative 1, and that's not what we want. So guys with positive exponents, stay where they are. It's only the negative exponents you jump down. We jump this x to the negative 3, and it becomes x to the positive 3. Now we're good. Our final answer doesn't have any negative exponents. Well, okay, next example here. Remember again, this exponent negative 3 only hits the guy in front of it at the end. So it's too far away for the 3, so the 3 has its own exponent, which is 1. Okay, well, here's what this equals. I've got a single 3. 3 to the 1 is just 3. But now, look what happened to the exponent for the ends. Okay, plus 3 and minus 3 gives me n to the 0. Well, I know that's just equal to 1. So the final answer in this turns out to simply be 3. Okay, a little bit more work now with some of these guys that have negative exponents and fractions. First thing you want to do is simplify the numerator and simplify the denominator. Denominator is simplified, but the numerator isn't. We've got this power to power here, and we have to do it first to see exactly what the exponent of this 2 is going to be. Well, remember, power to power we multiply, so this is going to be 2 to the, what do we got? Negative 4 times 3. I think it's negative 12. Okay, times 2 to the negative 1. Okay, well, what's my upstairs then? I've got 2 to the negative 12 and times another 2 to the negative 1. Same base, so we use the product rule. I've got 2 to the negative 13. Okay, downstairs I've got 2 to the negative 3. Okay, now I would not suggest that you try and reduce these negative exponents. I goof that up so much that here's what I do all the time. Before I do any reducing, I change all the exponents to positive. So the guy downstairs has to come upstairs. The guy upstairs has to come downstairs. So if we do that, then the 2 to the negative 3 goes upstairs as 2 to the positive 3. The 2 to the negative 13 comes downstairs as 2 to the positive 13. Now you can reduce and do it safely by the normal method. I've got 3 2's upstairs and 13 down. Well, the most I can reduce top and bottom at the same time is 3 of them. So I knock out 3 from the 13 and I have 10 left. So the final answer in this one's going to be 1 over 2 to the 10th. Well, let's look at a couple more here that are a little bit messier, but it'll show you again that if you use the cleanup process here, these guys work out pretty well. So here's what we're going to do. We got to do some cleaning up both top and bottom here. So let's take a look at what we can do. Now, on the top first, we got a power to power here, so we know we have to multiply the exponents. But remember, inside here, the 2 only hits the x. You don't see an exponent for the y, so we assume it to be 1. Okay, that being the case, then I'm going to multiply each of these exponents by 6. So I get y to the 1 times 6, which is 6. X to the 2 times 6, which is 12. Now, notice they got a multiplication dot here. Okay, that works. We know we're multiplying these guys. And there's a minus sign here. And let's see, the x is just to the first power. Okay, there it is. And the y to the third power. Okay, well, let's clean these guys up again. Remember the downstairs here, y to the 0 we know equals 1. So this would just be negative x to the negative 4 downstairs. Okay, well, let's go the next step in this. The upstairs, there's a single minus. So, okay, I'll put the minus here. Let's see, how many x's do we have? We're using the product rule. I got 12 here plus, times another x to the first. So 12 plus 1, that's going to be x to the 13. Okay, how many y's do we have? Y to the 6 times y to the third. That looks like 9 of them. So y to the 9. Okay, downstairs we have a minus sign. And we got x to the negative 4. Okay, well, first thing that happens, remember these two minus signs combine to a plus. So I'll put the plus there to rub it in. But you see this x to the negative 4, we can't have negative exponents in the final answer. So it has to go upstairs as x to the positive 4. Okay, well, we've gotten rid of the minuses. We made a plus. We took the x to the negative 4, jumped it up as x to the positive 4. So this becomes a 1 downstairs, which means the answer is just the numerator. Okay, how many x's do I have here? Well, this is product rule now. 13 times 4 more. We add the exponents, x to the 17. And, of course, we just had y to the 9, so there we go. There's our answer, nice and simplified. Okay, well, you go a step at a time with these negative exponents, and they're not bad. When you have a fraction, be sure you simplify the top and the bottom. Okay, well, here we go again, another fraction. The last thing we'll do is try and reduce it, but at the moment, notice I got a minus out in front. Here it is. Now, upstairs, we've got, let's see, just a single minus. Remember, this power of 4 is not hitting the minus. It only hits the y. This minus has its own power, if you want to think of it like that, just 1. So there's a single minus, that's negative. Now, how many x's did we have here? Well, x to the 5, so there it is. Now, remember, these are all multiplying. This is a multiplication dot. So y to the 5th times y to the 4th, we add the exponents, y to the 9. Now, downstairs, we have a power to power. Okay, something in parens raised to the 4th power outside. Now, inside, the negative 5 exponent goes to the y, and we're going to multiply it by 4. But the other thing is we will also have here 4 minus signs. Remember, okay, 4 of the minus signs. Anytime you have a power outside, it's hitting the parents. You've got 4 of everybody inside. 4 minus signs is an even number. An even number of minus signs, we know, just gives us a plus. So that means we have a plus downstairs. That's where that came from. Now, the y's. Okay, we power to power, we have to multiply, so it's going to be y to the negative 5 times 4, y to the negative 20. Okay, let's clean this up a little bit more here. Okay, here's the next thing. We can work with all the signs. These are the 3 signs of a fraction: sign numerator, sign denominator, sign out in front. Notice we have 2 of the minus signs, which again is an even number of minus signs. That means our final answer is going to be positive. I'll put the plus to rub it in. Now, y to the negative 20, I got to kick that upstairs, so it becomes y to the positive 20. So I moved all of it. So there's a 1 downstairs. That means the answer just upstairs. Now remember, we took care of all the signs. So what do we have for x's? Just 5. What do we have for y? Well, we used the product rule. I got 9 of them here and 20 of them here. So that's y to the 29. Okay, there's our final answer. 5x, y to the 29, and it's positive.